picks up and we continue on lesson 3.5 essentially. Okay, lesson 3.5 yesterday, they'd sometimes give us a picture of the graph, right? We'd be able to pull a zero, we'd use synthetic division, and we'd try and find more zeros, right? Okay, we're going to do some of that same stuff. However, they're not going to always give us a graph. So we have to come up with other options of, okay, if we don't have a graph, what are my options? Okay, how can I find some of those zeros? And so with that, we're going to talk about something called the rational roots theorem. It reads, given a polynomial, all possible rational roots, PRRs, can be found by taking the factors of the constant coefficient, P, divided by the factors of the leading coefficient, Q, and then X is equal to P over Q. Okay, so when you hear me talk about PRRs, this is what I've been referring to, okay? Possible rational roots, potential rational roots, however I say them. Notice what it says. We're going to find them by doing factors of the constant divided by factors of the leading coefficient. It's often expressed as this P over Q, but important to know is it's factors of the constant divided by factors of the lead coefficient. And we're going to practice that here as we go through this first problem. So right here, it's asking us to identify possible rational roots. List all possible rational solutions for each equation. What this is going to give us an option to do is it's going to give us a list of possible rational roots, the roots that we would see if we looked at the graph. But when it gives us this list, these are just possibilities, so it's going to give us the ones that are roots plus extras. Okay? So let's go through how we find this list, and then I'll explain a little bit more. Okay? So, PRRs. Okay? Often written as X equals P over Q. And it's said to do P is said to do factors of the constant. As you look at this equation, 4x to the fourth plus 13x squared minus 124x squared plus 212x minus 8. What is the constant in this equation?
Negative.
Constant is negative 8 because negative 8 is the one number that does not have an x on it. It does not have a variable. So right here on top, we're going to do factors of negative 8. Okay? It's a number without a variable. In the denominator, we're doing factors of the leading coefficient. What's my leading coefficient?
4.
4? Let me be nitpicky here. Which 4? The 4 in front or the exponent 4 is my point there. Okay, so where do we find the leading coefficient? In front of the highest power, right? So the highest power in this problem is x to the 4th. The leading coefficient is the number in front of that, so it's the 4 out front. Okay, so on bottom we're going to be doing factors of 4. Oops. Okay, now in all honesty, and you'll see as we go, whether you say factors of 8 or negative 8, it's not going to really matter. But factors of 8, what do we mean when we talk about factors of 8? Numbers are factors of 8. What do they do? They multiply to equal 8, yes? Give me some factors of 8.
2 and 4.
Okay. 2 times 4 is 8, yes? In other words, we often think in pairs for factors. What else multiplies to be 8?
1 and 8.
1 times 8? So you've got 1 times 8 is 8. 2 times 4 is 8. Any others?
4 times 2.
Okay. We can start switching back and forth, right? But it's still the same pair. Okay. So the numbers we're going to list are the 1 and 8 and the 2 and 4. I usually do them in order. Now, keep in mind, it did officially say factors of negative 8, yes? So we start talking about multiplying to get negative, you can take what? A positive times a negative. So like when we talk about 2 and 4, it could be positive 2, negative 4, or negative 2, positive 4. So with that in mind, all of these numbers that I list, you're going to see me list plus or minus. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Those are my factors of 8. Okay? Denominator. What are factors of 4? 1 times 4. 2 times 2. Anything else? No. Okay. I'm still going to list plus and minus with these because a negative times a negative can give me 4, can't it? So I'm going to list this as plus or minus 1, plus or minus 2, and plus or minus 4. Notice I did not list plus or minus 2 a second time, did I? Okay. I mean, you can, nothing wrong with that, but unnecessary. Okay. Right there, we've listed all of our factors of negative 8 divided by factors of 4. When you are asked to find all PRRs, all possible rational roots, then our job is to now put these in a list format. Okay? Right now, because right now those I've got numerators and denominators, but we're going to go through, I try and do this orderly. And so like I'll go through and say, okay, put everything over the 1. What are all of these if I, divide them out all over 1? And then I'll repeat the process with the 2 and 4. So what is 1 over 1? 1 divided by 1 is 1. So we're going to say plus or minus 1. What's 2 over 1? 2. So plus or minus 2. 4 over 1. Plus or minus 4. 8 over 1. Plus or minus 8. So that's taking all of my numerators and putting them over that first denominator of 1. Now repeat the process. Now put everything over 2. So what's 1 over 2? 1/2. Okay. So that's 1 over 2. What's 2 over 2? 1. What do you know about 1? Do we already have it in our list? We already have it. So do I need to list it again? No. Okay, so let's see. That was 1 over 2, 2 over 2. What about 4 over 2? That's 2, which we have. What's 8 divided by 2? 4, which we have. So you don't need to relist overlaps. And now we're going to take turns and put everything over 4. 1 over 4? Plus or minus 1/4. 2 over 4? 2 over 4 reduces to 1/2, which we already have. 4 over 4 is 1. 8 over 4? 2. Okay. Okay, guys, right here is your list of PRRs. Plus or minus 1, 2, 4, 8, 1/2, and 1/4. Yes, I have the plus or minus in front of them, in front of all of them. Okay. What this is a list of all possible rational solutions based on the beginning and end of this equation. Okay. Are these all going to be solutions of that equation? No. Because there's only going to be 4 solutions of this equation. So there's no way that all of these are going to work. But what this is saying is, as you look at a graph, these are possible solutions. Okay? We'll talk about when we go down this next part how we're going to use this list. But these are our possible rational solutions. Whatever rational solutions, so like what other whole numbers, fractions, decimals, are part of my answers, they are included in this list here. Okay? Okay, shall we try B? Seven x cubed minus 55x squared plus 21x minus 45 equals 0. Okay. Thoughts on PRRs? Okay, let's talk about where these numbers are coming from. What are we putting on top? Factors of what? Okay. So factors of our constant. Our constant here is negative 45. So on top, factors of negative 45. What about my denominator? Okay. Lead coefficient. My leading coefficient is the 7 out front. It's out front of the highest power. So factors of 7. Okay. Again, you can pretty much ignore the negative. But I need factors of 45.
1 of 45.
Okay. You got the easy pair. 1 in 45. There's always 1 in itself, right? Every single time. What else?
5 and 9.
Okay. 5 and 9. 3 and 15. 3 and 15. Did we get them all? And here's kind of how I check. So like, okay, so we said 1, right? And I'm going to write them in order, so I'll get to the 45 here in a moment. So we said 1 and 45. What about 2? Did we skip over 2? No, 45 is odd. Does it divide by 2? No, so we can skip 2. We already listed 3, didn't we? We said that was 3 and 15. What about 4? No, here's a hint, guys. 2 was an even number and it didn't work, so guess what? No other even numbers are going to work. So even numbers are gone. 5, we mentioned that. 6 is even, so no. Does 7 go? 7 go into 45? No. 8's even, so no. Does 9 go? Yeah, and 9 is the other part of 5, right? So that means I have all my pairs. I just have to list them now. So 5 and 9, 3 and 15, 1 and 45. So that's kind of a way you can kind of like count up to see, okay, did I skip any pairs? If I had to guess, maybe 3 and 15, I don't know. For me, 3 and 15 is the pair I would forget. I don't know if that's just me, but. Okay, what about factors of 7? Anything else? Nope. Factors of 7 are 1, plus or minus 1, plus or minus 7. Okay, now, we don't get to leave them like this. We need to go through and make our list. What am I going to suggest you do first? Put everything over 1, right? And if you have a different way to do this and get all your answers, that's fine. This is just my organization. So I'm going to put everything over 1. 1 over 1. 3 over 1. 5 over 1. 9 over 1. 15 over 1. And 45 over 1. So plus or minus 1, 3, 5, 9, 15, 45. Now what? Put everybody over 7. Okay. What about 1 over 7? What's that? 1/7. 3 over 7? 3/7. 5 over 7? 5/7. 9 over 7? 9/7. Where am I at? 15 over 7. So plus or minus 15/7 and 45 over 7. Unfortunately, this time none of them overlapped, did they? And that happens. Sometimes you get a lot of overlaps. Like last time, there's a whole bunch we didn't have to end up listing again. This time, I got no overlaps, folks. And you've got that big old long list. Okay? Which is why you have to stay organized about it. Now, the comment was made first hour, do we have to type these all into SOPIS? And if I recall, at least some of them are multiple choice. Like when your directions are just list all possible rational solutions or possible rational roots. I don't know if all of them are, but very possible. I know there's some multiple choice involved. So it's going to be going through and figuring out which multiple choice list to select. Now, when you do something for me on paper, I'm going to want you to list them all out though, right? Okay. Don't leave them in this fraction form here where we don't have them paired up. Go through and get them paired up. Okay. Questions here? Okay. Well, let's go down to the bottom and look at how we can use these. In the bottom section, we're being asked, what are all the complex roots of the polynomial equation? Write the polynomial in completely factored form. So we have two pieces. We need to find all complex roots, and then we have to write our answer in factored form. Now, as you look at this, yesterday if you were asked to find all the roots, you would have a starting point, right? Usually there's a graph provided, and we could grab information from the graph. And I'm trying to think, if there wasn't a graph provided, like the equation was factored, we'd have some kind of information. This equation isn't factored. I don't have any ideas here. And I don't have a graph, do I? So we need a plan B. And our plan B here involves using our PRRs. Okay? We're going to use our PRRs and then go from there to find which ones work. Okay? So I tend to try and think steps here. And I'm going to call this step 1. And in step 1, we're going to find our PRRs. Possible rational roots. Okay? So this is the P over Q, or in other words, factors of what over factors of what? Okay? So on top, we're going to say factors of -2, because that is my constant, over factors of 3, because that is my lead. Now, I think first hour, some people regret I didn't tell them. I have a lot of information to write on this problem, just kind of FYI. So, don't write huge, I guess is what I'm saying. Okay. Factors of -2. Is that easy? Factors of 2, right? So I'm going to say plus or minus 1, plus or minus 2. Factors of 3. 1 and 3. Now, I would encourage you, like this part is not the graded part in this problem necessarily, but I would still encourage you to go through and make the list. So if I'm making the list, I'm going to start by putting everything over 1. So 1 over 1 and 2 over 1. So plus or minus 1, plus or minus 2. What else? Put everything over 3. So 1 over 3 is 1/3. 2 over 3? 2/3. Okay. This right here, and again, it's not an answer or anything, but those are my PRRs. Okay? Those are my possible rational roots. And that is step 1. Okay? Now, technically we have what? 8 numbers there, don't we? When you think about 1, -1, 2, -2, and then the others. We have a couple options here. Okay, because here's what I need, is I need to figure out which ones are legitimately true rational roots. I know not all 8 are, because I know at most there's 4. Based on the problems we're doing, there's probably going to be some imaginaries in here, so there are probably not even 4 of them that are from this list. Yesterday they gave me a graph. I don't have that today. So, officially, our option is supposed to be we start taking these numbers and we start guessing. Okay? And how do we try and find out if a number works? What were we doing yesterday? We'd take the number from the graph and then we'd use what? What were we using to factor it down and... Well, but before we could even get to that point, after we took a number from the graph, we had to try it and see if it truly did work, right? Synthetic division. So, officially, one of our options is take these numbers and start trying them with synthetic division. And go until we find something that has a remainder of 0. Are these all going to work? No. So are we going to have some problems where they don't actually work? We are. So officially, I think that's what I'm supposed to teach. Now, we're going to shortcut it, because do you want to sit here and try all 8 of these? Probably not. I don't really want to sit here and try all 8 of these. We're going to take a peek at a graph. And then, because what we're going to look for and see is, do we see any of these on the graph? How can we take a peek at the graph? Desmos. Okay, so what I'm going to call step 2 is that we're going to check Desmos. We're going to check the graph on Desmos for any of the PRRs. Okay, I'm going to write that step out and then we can look at it. Check graph on Desmos for PRRs. Okay, because then those are the ones that we're going to move forward and use. Okay, so grab the iPads, put it in Desmos. So once you get it typed into Desmos, what is it you're going to be looking for? Where the graph does what? Crosses the x-axis, right? Oh, shoot. Oh, no. Oh, I guessed right. Okay, you do not need to put the equal 0 in. I don't know if putting the equal 0 in would hurt you or not. I'm not sure what putting that in, but you don't need to put the equal 0 in. Are you getting it figured out? Is there a way to do exponents other than the squared? I was struggling with that this morning. Because I couldn't see it online. Or at least when I had it pulled up this morning. Oh, there. I don't know what I thought that said. Okay, yeah. Okay, Thank you. I'll be honest. First hour, I had to change my pad to do my 90-day password change last night, and I forgot to update the Wi-Fi password on here. So I didn't have Wi-Fi on here, so I didn't get Desmos to go pulled up during first hour. So then I typed these in during homeroom, and I didn't even see that A to the B. Okay. So, what's the graph tell us? What do you see?
Greater than -1.
Okay, and here's the deal. I know with Desmos it's easy to just tap on the graph and see what it says, but I don't even necessarily need you doing that. I just want you eyeballing. Like if we eyeball, okay, that looks like -1, yes? What about the other one? What's that look like? Without tapping on it would be my challenge. And when I say what's that look like, as in including values from our list, yes? We had on our list what? 1, 2, 1/3, and 2/3. So -1 here was from our list. Our fractions on our list were 1/3 or 2/3. That looks more like a 2/3 than a 1/3, doesn't it? And these are kind of guesses. Do I know 100% sure they're going to work? No, I don't. Okay? Because again, I'm just using this to get ideas. Okay? Are we good with Desmos? Because I don't know. I guess I've been out of Desmos enough. I struggled this morning for whatever reason. So, okay, let me go back here. So we're going to try x equals -1, and we're going to try 2/3. And the reason we're going to do that, I'm just going to put a little sketch here, is that because this graph didn't do exactly that, did it? We didn't have but. This looked like a -1 to us, and this looked like a 2/3 to us, right? Okay, so that's why we're picking to try -1 and 2/3. Okay. Now, that takes us to step 3. We've got a couple of possibilities. What do I do in step 3? Yeah, we're going to do synthetic division with both of these, similar to what we did yesterday. So I'm going to start with my nice, neat whole number. I'm going to do -1. What do I put in my row next to -1? 3, 4, 2, -1, -2. Do I need any placeholder zeros? No. We've got x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and constant. So no zeros there. Okay, you guys know synthetic division, right? Drop the 3. -1 times 3 is -3. Add 4 plus -3, 1. Multiply. -1 times 1? -1. Add 2 plus -1? 1. Multiply. -1 times 1? -1. Add -1 and -1? -2. Multiply. -1 times -2? 2. And add. -2 plus 2 is 0. Okay. -1 worked, yes? Okay, that remainder of 0 tells me so. We kind of expected it to work, didn't we? Now, I'm going to go ahead and have us think about this for later. Later, we're going to have to talk about factored form, aren't we? What does -1 tell me there's going to be a factor of? There's going to be a factor of what? X plus 1, right? It's technically x minus -1. So there's going to be a factor of x plus 1. Okay, what's next? We tried -1, it worked. We need to try 2/3. Yes, it's a fraction. Did we do a fraction yesterday? I don't remember if we did or not, but here's what I will say. If you have a fraction that you're using with synthetic division, and it's going to come up with a remainder of 0, the math works out really well. Okay, so don't freak out that she's making us do this with a fraction. If it's going to have a remainder 0, it's going to work out nicely. Now, what do we use as our row of numbers? Yeah, you need to go back and use the answer from the previous problem. Okay? So we need to use the 3, 1, 1, negative 2. That is important because just like yesterday, we're trying to get it factored down. Okay? Drop the 3. What is 2/3 times 3? Yeah. Yes? 2/3 times 3. Think of it as multiplying by 3 over 1. 3's cancel, and it is 2. 1 plus 2 is 3. What's 2/3 times 3? 2 again. 1 plus 2 is 3. 2/3 times 3? 2. Negative 2 plus 2? 0. Did it work? Yeah, it worked, which is what we expected. So 0 worked. 2/3. Now, I don't remember exactly how they have you put it. You may have to go ahead and look at this, but what would you say about with 2/3 as a factor? X what? Minus 2/3. Okay, I need to go back into Savas and see if they would let you write x minus 2/3 as an actual factor or not. I'm not 100% sure if they do. Okay, but I have that in my notes, so we're going to go with it. Okay, so step 3 is using our zeros and synthetic division. And now, out of all of that, we get this 3, 3, 3, yes? What is this 3, 3, 3?
3x squared plus 3x plus 3.
Okay. You guys, are we getting to be pros at this? It was originally what? X to the 4th? So this became x third. This was x to the 3rd, so that means this is now x to the 2nd. Okay, so that means this piece here is 3x squared plus 3x plus 3. Okay. They asked us to find all zeros, so we need to keep going with this. And this is what I call step 4. Okay, we're going to take that equation there of 3x squared plus 3x plus 3 and set it equal to 0 to find the other zeros. Thoughts on where to begin?
Divide by 3.
Okay, can we divide a 3 out of there? We have an equation equals 0, and in all honesty, you can honestly, I'm not even going to factor it out and put it out front. I'm just going to divide it out. So I'm going to have x squared plus x plus 1 equals 0. That looks a little bit nicer, right? A little bit smaller numbers to work with. Okay. Thoughts of how to solve?
Factor.
More power to you. You got numbers that multiply 1 and add to be 1? And here's what I'm going to tell you guys. It's not going to factor. We already know our 2 rational roots here. Those are the only 2 roots it showed on here, which means these other 2 roots are going to end up being imaginary. Okay, because how many answers am I going to have here? We're going to have 4. I only saw 2 places on the x-axis on the graph, so my other 2 are going to be imaginary. So if it doesn't factor, what's plan B? Quadratic formula. Okay, so x equals negative b, so negative 1 plus or minus the square root, b squared, 1 squared, minus 4 times a times c all over 2a. And this is where a, b, and c's are all 1s, yes? Okay. Clean up. Negative 1 plus or minus, what's going on under that square root?
1 minus 4.
Okay, 1 minus 4, and 1 minus 4 is? Negative 3. So I have negative 1 plus or minus the square root of negative 3 all over 2. Okay. Negative 1 plus or minus, what do you know about the square root of negative 3?
It's I squared.
Okay. The square root of negative 1 goes out front as an I. The 3 is going to stay under the square root. So negative 1 plus or minus I square roots of 3. Now, what does this represent right here? This represents two solutions, yes? How many? What are my other solutions?
X plus 1 and X minus 2.
Well, okay, so the solutions, though, are the negative 1 and the 2/3. So what I'm going to say here, the first question of this problem asked me for all roots. When it's asking for all the complex roots, the negative 1 plus or minus is 2 of them, right? And then negative 1 and 2/3. Now, what else did it ask us to do? In this particular problem, it also asked us for factored form. Some problems will ask for factored form, some will ask for the zeros. It will just depend on the problem. Now, work with me real quick on factored form. I tried to get factors as we went along. What was the first factor we had? X plus 1. What was the next factor? X minus 2/3. Now, in Savas, they don't want factors involving I don't think. So these right here, we're not going to put these into factors, but where did these come from? These came from this right here, or this right here. Okay, so my third factor that I don't know if I have room to write, 3x squared plus 3x plus 3. Okay, and that's just because that one does not, it factors into i's. Okay, so we're kind of building on what we were doing in 3-5. Okay, tomorrow we will pick back up in 3-6. We'll pick back up on B, and then we will also look at the backside. Okay? If 3.5 is not done, get it done today because you don't want it building on to 3-6. Okay?